All right, I guess that's my cue. Thanks for coming to my subject, which is talking about converting content to FHIR with a particular focus on HL7 version 2 and CDA. So I'm going to focus on methods, understanding the problem of conversion generally, and we'll illustrate with version 2 and CDA because they're the most important prior content that people already have engaged with. And look at doing conversion by code. We're going to talk about table mapping forms. We're going to look at the FHIR mapping language, and we're going to talk about a new project I'm working on, the JavaScript Sandbox. So, and the reason this matters is because nobody's, or very few implementers start with a clean slate and say, my data is going to be FHIR, it's always going to be FHIR, that's all I deal with. It's pretty much something that doesn't happen. Everybody starts with content all over the place in all sorts of formats, and even if you have it in FHIR, you need to move it to other formats as well. So let's start with common problem statements. First is CDA. We're going to convert CDA, a clinical document, to a bunch of resources, a bundle or a set of resources. As an output in FHIR, we're going to get a composition that links everything together. We're going to get a patient and practitioner, a bunch of sections, each with their linked resources. Probably what we're really after is those resources. Typically, the document, the CDA document, does the document purpose fine, and you're actually extracting in order to get it the data inside the document and be able to do other things with it. Now, common problems that we have when we do this work, and lots of people have done this now, is challenges around mapping the actual CDA section content into resources. They're sort of structural. The structure of a composition and its resources is very similar, but you have the acts in CDA are a little bit more abstract than the resources, so there's a bit of challenge there. And the resource type that you actually choose depends on class code, mood code, the context you're in, the resources you're dealing, the content, the codes you're dealing with. There's a few cases where things that are apparently clear in CDA are not clear in FHIR. It's because there's some abstract stuff in CDA that seems really clear from a CDA point of view, it's just unclear from a record point of view, and vice versa. And some of those in CDAs, a lot of those surface as status code questions. What does it mean when you have a allergy intolerance status code of complete? I've seen a variety of interpretations, things like that. And so there's some areas of mapping where actually you can say things in CDA that you can't say in FHIR, and we think, by and large, those are things that don't make sense, but they come up. For those of you who love GTS data type, it can be particularly difficult to map from the GTS data type to the FHIR data type, timing data type, and vice versa. And in fact, when I did the data types in FHIR, I basically started with the CDA requirements and said I'm just going to recode these in a simpler to use form. And by and large, the data types have held up. We've moved some content requirements around, but it's in timing. We've completely beefed up timing. It's far more functional than GTS. The other thing that's a real problem if you're doing CDA work is there's no penalty for the author of the CDA document to lose record identification information. And a lot of CDA documents I look at, people basically lose the link back to the source record. It's a document. Why does it matter? So you process the document into a repository. They send you an updated document, maybe they send you a provisional discharge summary, and then they send you a final discharge summary, and you get the same batch of medications, but they're a little bit different. Just how do you match them, or are they different medications? If you get another discharge summary and a different set of medications, when are they updates to a record you've already got, and when are they not? My easiest way to do this is if they carry a consistent, persistent ID, but often they don't. And so reconciliation of those may be difficult or sometimes impossible. So those are the common problems that you have in CDA, and then each CDA document's a little bit different. We try to drive that stuff out, but that's hard work. The other common problem people have is a V2 message. You've got a stream of V2 messages coming on the interface, and you're going to process them into a repository. That's what most of us do with version 2 messages one way or another. In this specific case, it's a FHIR repository. It doesn't have to, it's the same basic problem, and a lot of the challenges are the same, whether you're doing FHIR or just a database or something. So you get a transaction coming in as a message. You're going to, in FHIR, convert it to a transaction, which means you're going to process the message header, figure out what it is, you're going to figure out what actions you should take, create or update a patient, encounter, a bunch of other segments. Some of the segments will get folded into other records, and some will become multiple different resources. That's a fairly common thing for people to do. And just the same again, what are our challenges? So whether you have an existing record that you're matching to an existing resource, because you've already seen this segment or the record this segment represents before, that's one of the great challenges of processing version 2 messages. That's nothing unique to FHIR. If you're decrypting a stream of version 2 messages coming into a database, and most of us will have, or a lot of us will have done that, then that's a classic version 2 processing problem. And it permutates all through your work. And update business rules can be significantly complex. It's not unusual when you look at a typical version 2 receiving set of code to find that most things just from here to here to here to here to here to here, and then 100 lines of conditional logic about what to do next. That's not unusual. Then there's our favourite rabbit's ears, the cell, the data of the field with 2 double quotes. If you ever want to get a good argument amongst version 2 experts, ask them exactly what it means. Because everybody uses it for slightly different reasons to convey a slightly different idea. And in general, the 2 basic choices are, I put in rabbit's ears because I didn't have anything else to put in here, and I put in rabbit's ears because I had something else, I want you to take it away. Of course, whichever there's no general answer to that, you have to actually find out. And the other big fun thing with FHIR, with V2, is you get a sequence of OBX messages. OBX segments. What exactly does that mean? And there's probably 5 or 6 main different ways to associate meaning to the sequence. And is there implicit structure or not? There's OBX3, but then there's other ways to do that too. And the other big problem with version 2 is most identifiers you get are local to the interface, and they are not scoped. And we say, after decades of experience, that's a terribly bad idea, and you must scope your identifiers, but you didn't get any scope, and so then that's a significant challenge. You have to actually chase that down for each version 2 message. How do I uniquely scope this identifier? So those are some of the challenges that you deal with. So just a bit of theory then about mapping. A basic rule of thumb that I've found in my work, which is I've been transforming data, that's mostly what I've been doing. About 90% of elements are simple one-to-one mappings. There's nothing really very significant to say. It's easy. Then about 9%, what's left, involve some restructuring or conditional logic. And so you might have a series of named fields that get moved into a list of coded values, or vice versa. Or you may have fields that go here in some cases and here in other cases, depending on the value of another field. And so you need to express some logic around that. And then you get to the last 1% of problems, which are very, very hard indeed, around OBX sequences and figuring out the context and mapping against existing records and so forth. And so that's my general experience. So then you talk about how we're going to map. We're going to map from V2 to FHIR or from CDA to FHIR. And what are we trying to achieve? The first thing we don't want to add complexity to the problem. The problem is hard enough without us adding to it. So whatever approach we take, we want to actually be faithful to the problem but not add to the complexity. But on the other hand, we do have to be complex enough to actually meet the requirements. So you might say, I'm going to build a solution for this based on a simple visual mapping paradigm. And there are commercial products out there that do this. So I draw lines to link up my source and my destination. That's really, really good for the 90%. It gets difficult for the 9%. The 1% left, and patch it up later with code, very often is the answer. And so that actually turns out to be much worse than some other approaches. Another thing that has to be done is fast enough. And fast enough is a tricky term. If you have messages coming in on average, or documents on average once a second, and you are taking 0.99 seconds to process the documents, and it's a linear interface, then on average you'll have 3 or 4 waiting, and you'll basically keep up. But if you take 1% longer, by the end of the day you'll be hundreds behind. So you just have to be fast enough for your throughput. And that's the key number, is what is your throughput. But what's really key for me is that most of the mapping activity that goes on, most of that I've ever seen, it's a solitary activity. One person sits down with the requirements in one place and does a one-off mapping. And doing that mapping, they learn a lot, but then that disappears. They can't reuse the mapping because the framework of their mapping and their decisions are driven by, partly by the problem, but also partly by their context, their engineering solution, and there's no way to pluck out the reusable bits from the bits that are bound to a particular system design. And so my experience of mapping is it's a solitary activity, and that it's a costly solitary activity. So the thrust of the work I'm trying to do in FHIR is to take mapping from a solitary activity to a communal activity. And to do that, we need to make the mappings portable so that multiple systems can implement the same mappings, and you can start thinking in terms of system as a separate question from the innate information problem. So just a couple of first principles. We can think about almost all the data that we're going to run into as directed acyclic graphs, which are commonly called trees, a root element with an arbitrary, mainly irrelevant name, a set of elements that have primitive values or named children, named types, and cardinalities. It's a pretty common model. The big exception, of course, is databases, which are not necessarily acyclic, but often we can treat them as acyclic anyway. And the structures are different between each other because they use different names or properties or repeats with codes. There's underlying reference models that derive differences in designs. More importantly, sometimes the models are different, the content's different because people have a different understanding of the actual problem. They cared about different parts of the problem. So it's not unusual to go to map from one system to another and realise you can't actually do that because one system's dealing with one set of requirements. The other system has a separate set of requirements and they only partially overlap. So that's pretty common. And the other problem is that expression of information is fractal. The level and the granularity at which you express information, that itself, everybody has a different take on that. And it seems to me that there's more of a problem in healthcare than other data. Like, as I've been through the standards process, people have come to us with mapping languages, mapping frameworks developed for telecoms and banking, and I look at them and go, you can't seriously think that that would work in healthcare, and they're using it in production. So I don't know what's going on there, but I think we have more complex data. I'm not sure. All right, another thing to talk about is the level at which you map. So I think of the mappings in 4 different levels. I've got 2 sets of trees with schemas, and I'm going to map between them. The first set of mappings is what I call skeletal mappings. I'm going to map the backbones. I'm going to tell you about the big decisions you need to make. And I'm going to leave it to you to figure everything else out because it's pretty obvious. It's by far the most efficient way for me to map something because I don't actually have to do all the work. I just hand it on to other people and just tell you the really important stuff. And if you look at the version 2 mappings and the version 3 mappings in the FHIR specification, that's really what we're trying to do. We're giving you the signposts in the direction that you should go. We're not doing all your work for you. The next level is you say, I'm going to actually map the elements in the class models. I'm going to map them one to the other and say, this element corresponds to this element corresponds to this element. And this really works really well for simple things, but you've swept a whole lot of stuff under the carpet. You haven't actually worried about whether the types and the value domains are truly compatible, and you haven't worried whether the data is actually directly transferable. You've just said these are the same thing. And so this is a conceptual mapping. And you're still left to your implementer a huge amount of work in actually figuring out how do I actually move the data, because you can say actually 3 different fields map to 5 different fields with a many-to-many mapping, and the actual mapping depends on other values. Conceptually, that's how it works. So it's I call it concept mappings. And then we get and say, okay, let's go beyond that and actually start mapping all the way down to the primitive types and make sure that the primitive types are all mapped. And you could call that a detailed mapping. It's similar in concept to the concept mappings, but you just go through all of the primitive, you keep driving down to the primitive level. But even when you've got that, there's still lots of problems associated with the mapping that mean that someone has to sit down and actually write code that reasons about the mapping. And the most obvious is cardinality management. I've got 3 fields that map to 3, in one class that map to 3 fields in another class, and one of those is a repeating field. Do those other fields map with the repeated fields so that we have 3 of classes, we get multiple classes, or do we just collapse them into one class and overwrite them over another? Those kind of problems, and how do we handle errors, and have we checked the entire value domain of all the incoming so that we can produce the correct value domains in the outgoing? By the time you finish doing all that work, you finally have an executable mapping, a set of rules about the relationship between the source and the destination that you can feed into an engine, and the engine can do the conversion for you. Nobody likes reading executable mappings because they look suspiciously like code. They're not necessarily helping with the problem. And that's part of the problem, is by the time you get to an executable mapping, you're almost certainly bound to some system engineering artifacts, which mean that it's actually less useful for someone else because they first of all have to un-engineer out your system-specific engineering so they can actually understand it. So when you actually look at the mappings that you see floating around for FHIR and version 2 in CDA, so it's version 2 to CDA and back, you'll see a range of detail here. Sometimes you just see skeletal mappings, and other times you see conceptual mappings masquerading as executable mappings, or vice versa. Pay attention, because these problems are all real. They have to be solved, but people are often loose about what it is that they're doing here. So the first and obvious way to convert the content is with code. And everybody defaults to doing it with code. I certainly did for many years, default to doing it with code. Some programming language, the programming languages are loaded up with free libraries, or, you know, if you can't think straight, you could use XSLT, which a lot of people do. I don't like state engines, really don't like state engines. But and in fact, transforming data is the #1 application for your language of choice, for any language of choice, because that's what we all do all day, every day, transform data. And it always meets the complexity requirements because it's basically a general purpose computing engine in a language. Skills are always at hand for some value of at hand, and there's always programmers available. And it's generally pretty fast to execute. I mean, you could choose perhaps an inappropriate language, an excellent language like Visual Basic, but generally they're pretty fast. Well, why is that not the answer then? Why would we just not say use code? And in fact, on Zulip over the years, I've said, just use code quite a bit. But why is that not the whole answer? Well, which language are you going to find the skills you want for the language you want? But code definitely depends on external facilities. You bind into a particular database access framework or a particular database design, and you call on a bunch of libraries, and the choice is driven by system architecture. And you could isolate all these things out, and I might come back and argue that you should, but people don't. Also, code is compiled, and there's deployment restrictions, and code goes through reviews and so forth. And actually, people who can write code tend to be more expensive than other kinds of people who might be able to solve this problem. So for a lot of reasons, people tend to try and avoid depending on programmers if they can. But nevertheless, mostly code is what gets written, and it's an honourable tradition. I don't want to dishonour that tradition. The next thing you're likely to find after code is some kind of table mapping driven approach. Some form of column-based table on a spreadsheet or a database. It's a really obvious thing to do, and anyone who's not a programmer, that's what they start and say, well, that's what we're going to do because that's how you do it. I don't want to write code. And it is a very obvious thing to do, and it handles the 90% really, really well. The first 90% of your problem. And of course, typical system analyst, I've seen this again and again. If the project's 3 months, 2.5 months in, it's going great because they're still doing the 90%. And they're about to hit the wall. I've seen that before. So it maps well when the names are different but the value domains are the same. But once you start getting into variable value domains and mismatched requirements and conditional logic and so forth, it starts to get difficult. And then what you see, and I love seeing this, is you start seeing people making up ad hoc DSLs, micro DSLs inside their mapping tables to start adding complexity as they run into the stuff they kept kicking down the road. And eventually you get basically an ad hoc DSL buried inside a table. And I've seen quite a few people in the room nodding, saying, yep, seen that. All right. And in fact, HL7's doing that right now. Here we are. We have a project working right now to provide some really comprehensive, that's the word they use, comprehensive mapping between version 2 and FHIR. Is that a concept map or a detailed map or an executable map? Well, I can't get the team to think straight about that question. But here's one of their spreadsheets. So on the right-hand side, left-hand side here, you've got the V2. This is the MSH segment structure. The identifier and a name. The display sequence here is so I can reorder the table. And a data type and a cardinality. Over here you've got a FHIR attribute where it's going. The data type of the FHIR equivalent, that's to help map the value domains, although they don't actually map the value domains. Here they have a nested mapping for mapping inside those tables, along with a bunch of comments, plenty of comments, and they're always worth paying attention to because that's where all the complexity gets hidden in a typical project. Here, if you can see it, probably some of you can't, but you start seeing the micro-syntax creeping in, right? Where we're going to start trying cardinality management, some delegation of content. I skipped out the conditionality field. I think I've got some conditions here. So you start inventing DSLs down here, and this is PID, and you're starting to express more complex content, extensions, vocabulary mappings. So this is a pretty typical approach, and we're currently working on that. And so I think we have a lot of work to do to turn this into something that's really presentable to a wide audience. But there's an incredible amount of V2 knowledge in here. And it's a wonderful resource. If your actual problem is to convert from V2 to FHIR, my advice is don't at this point think that you should process this programmatically, but think of this as an incredible asset for a human who's doing the job. And this, we're working towards publishing this. There's still contention around what exactly we're going to publish, but the knowledge in here coming out of the V2 experts is just amazing stuff. Although, as usual with V2, your particular V2, yeah, well, this is only advisory. And there's nothing we can do about that. All right. So that's a pretty typical table mapping approach. They're tremendously good, and I do want to emphasize this is a tremendously good way to handle 90% of the problem. But somehow, you've got to stop the people authoring the tables. You've got to stop them from getting out of control on the DSL thing, because they will keep inventing arbitrary syntax to say what they find that they have to say. And if you don't have, you need to have a breakout approach. Say, okay, we're going to stop with the table at some point. If you don't have that, it becomes a never-ending cycle. And you won't, unless you do address the last 1%, you can't completely automate the transform based on the information. So it may be documentation that you use to support your coding process, or you might call it from your coding process to do all the easy stuff, and you just do the hard stuff from the code. Well, there's a variety of ways to handle that. I'm not saying this is not a useful approach. You just have to understand its limitations. And this is, in FHIR, it corresponds roughly to concept map, an element mapping in concept. And when we publish it, we'll publish at least concept map. And there's a concept map resource, which I'm not going to talk about. So we're still working on the goal, which is really those spreadsheets are really working really wonderfully for, is to make mapping from version 2 to FHIR a community activity. That part is working really well. But we're still working on the infrastructure. So the next thing is the FHIR mapping language. So this is a formal DSL that we wrote from scratch to take this problem on, to do executable mappings. So our design features, we wanted to describe a transform from one instance to another, where the instances are trees of elements. That's our problem space. We chose to describe one-way transforms, and what we wanted was formal statements of relationship with no procedural content. There's no assertion of processing order. There's no assertion of variables that you can update the values of. There's no assertion of sequential behavior. So it's entirely declarative statements of relationship, but you can declare dependencies. And it's based on a structure with a hierarchy, so that there is some ability to use graphical transform builders as long as you have a breakout to express more difficult ideas. And it's modular to allow reuse. And it doesn't actually depend on typing information. And so that was what I sat down with. I sat down with the author of the QVT specification from OMG, and we designed this. It was not the language I thought we were going to design, but it turned out it's what we designed. And it's expressed in the resource structure map, which is a resource like all the others, with the same metadata, but it's actually the abstract syntax for a concrete syntax, which is what I'll show you from now on. And it should contain the concrete syntax in its narrative. And we have forms that convert between them, and we support the form of the text form. So the text format looks something like this. Given a declaration of left and right, which are implicit to the mapping language, but they exist, then you say, this is a map, which is from the tutorial in the spec, that says I'm going to map from source to target. I'm not going to do a tutorial on the mapping language here. There's another session on the mapping language, which I recommend to you. And then you might write rules given left and right from A1 to A2 that says for A1 make A2. And that's not, it's a declaration of the mapping relationship. It's not an assertion of a sequence of activities. I'm not going to go deeply into this, but you can reorganize, for instance, you notice that the cardinalities are moved around here. This is actually a relatively complex mapping problem. And here's the mapping statements that will reorganize from this cardinality to this cardinality. I won't go through them in detail. We sat down and we did all the requirements that we'd ever run into in terms of nasty mapping problems, and that's what we came up with. So there's a bunch of version transforms. For instance, converting from release 3 to release 4 is done with the mapping language, and we have some CDA mapping languages that we're working on, mapping statements. But I presume that what we end up with CDA will be some combination of table-driven mapping and declarative mapping language. So the mapping language is really portable. There's no system dependencies in the mapping language. And because the mapping language has a total ban on procedural code, that means it's really conceptually challenging. It's like a head change to sit down and say, okay, I'm going to use a mapping language to map from A to B, and everybody's used to saying, well, there's some things that I'll do procedurally, and I'll think about looping through the content and handling the content like that. And the mapping language says, nah, you got to think differently, and it's a real change of perspective. But what it does do is it allows you to know, instead of feeding a single instance into the mapping language engine and getting out a single instance, you can actually feed a set of instances, a profile, into the mapping language and get a profile out. Right? It's possible to write that because there's no, because every relationship is declarative. You can actually map the whole value domain. So you can, given a version 2 specification and a mapping language, you can produce a FHIR profile. It's actually pretty magic, and there's a bunch of really useful consequences of that. But because there's a ban on procedural code, it requires you to think differently, and it requires you to commit to those goals and to those outcomes, and so adoption is pretty slow. And we're sitting watching that, wondering whether that means that we did the wrong thing. But actually, the adoption is real, and the libraries are starting to come and so forth. But actually, the key feature of the mapping language that makes it portable, and remember to go back to my goals. My goals are around portability. Mapping language is a step in the direction of portability. The API is what makes the mappings portable. So here's the API that you can depend on in the mapping language. The value set validation, translation of terminologies, looking up other trees of data, creating an instance tree, and returning a correct string format to refer to a tree. And then all those are all the system things. They're different from system to system. You delegate those out to the system and just assume that they'll happen, and the system can figure out, are we doing a website? Are we doing a FHIR database? Are we doing a database directly? And actually, the mapping logic doesn't need to worry about any of those things. It's totally independent of system decisions. And it's this API that creates the portability from one place to another. It's not the mapping language itself, it's the API. To go back to code then, you could write this API and then write your code entirely wrapped by the API, and anyone else who writes the API can use your code, so the code itself becomes portable. So we started thinking about that and saying, let's actually push on that. And so what I have is a proposal for a JavaScript sandbox, and there's the link to the proposal, and it's come back to life now that I've got the FHIR technical correction out. So it's a standard sandbox that any application can implement, whether they're an integrated engine inside an interface engine, or it's a canned Lambda function running on the web, in the cloud somewhere, or it's in some clinical application, and you need a standard JavaScript engine that provides a bunch of APIs to JavaScript, and then people share the JavaScript that is framed within the mapping API. So a JavaScript entry point, every JavaScript that you write starts with this common entry point. It says I've got a bunch of services, I've got an object I'm going to convert, and I've got a handle to a FHIR API, and I'm going to orchestrate the mapping in JavaScript. And you've got these JavaScript functions you can call on to do the API functionality. I can go through them. And then there's these. You can either just write JavaScript code, pure JavaScript coded solution. But from the API, you can call out and say, run another JavaScript, or run a mapping language conversion, or run a liquid conversion. You can even use Markdown, which is kind of useful sometimes. Given those things, you can actually call out those other facilities. So you can actually, and we're going to add a table-driven one for those V2 table formats. So you could say, okay, the V2 table format solves 99% of the problems, sweet. We'll use those directly, and we'll call them from our JavaScript, and we'll do the other 1% in some other code that we actually handwrite the code. So that's the Sandbox. And here's an example, a typical example. We start with the JavaScript entry point. We say we're going to, from the V2 message, and there's a UML specification for a V2 message, we're going to pull out the patient ID, the patient segment. That's the second segment. In this particular message, we assume it's the second message. We're going to pull out the patient ID. We're going to look up the patient ID in the API and see if we've already seen this patient before. If we've seen the patient before, then we'll update the patient record out of the resource, which is a whole different mapping problem. Or, if we haven't, we'll make the patient resource, and I think I have an example for that. Making the patient resource runs a little liquid script. Liquid is a really great way for simple mappings. And we're working on liquid and building liquid into the spec, so you can look that up if you want. And then once you've built, you build the resource, you fill out the patient ID, and then you send it to the API, and then you return what you get back to the previous script. And so you do all this in JavaScript, you're entirely wrapped. All you need to do is express the logic of the conversion. And if you do that within the Sandbox, the code that you write to express the logic of the conversion can run in any system that implements the Sandbox. And so that Sandbox actually enables the portability. The mapping language uses the same Sandbox, and anybody who implements that Sandbox and passes the test can use your code. So, that's work in progress. None of the options that we have are really perfect yet. I don't know whether we'll get them perfect, but our focus will remain, an obsession will be on making it a community process, doing mapping, rather than a solitary process, solitary thing. Because I think that the principal cost of mapping is the fact that it is primarily a solitary activity, and I want to move that to being a community activity. So thank you very much. I've got a couple of minutes for questions, if there are any questions. Sorry? Yeah, there's always questions then. There's always Julep too. But if you're interested in what I said about the Sandbox, you are very welcome to read this link, which I will put on Julep to make it easy for people to find in the Implementers channel, and make commentary on the use of the Sandbox. And the Sandbox will support other ways of mapping as efficient mappings, and really the intent is that the JavaScript is the orchestration of the mappings and not actually the way that you do the mappings. Yeah.
Will this be part of the FHIR standard itself, or just something that you're on the side?
I think the Sandbox will probably be a separate specification. But if it goes well, I would like the Sandbox to be a formal standard. But yeah, I think it's better as a separate standard because it's a different kind of artifact on its own life cycle. Yeah. Can you say the last sentence again a bit louder? Yeah, it can do it. You start with a single tree, but you can go off and ask the system for other trees that are related based on some criteria. I think the mapping language, you can feed it multiple trees outright. It's a bit hard to figure out how you would why you would initiate it, how you would initiate that, how you explain Why would you be passing in multiple trees? That itself is a bit strange. But you can do things like that. We've got examples. For instance, in the R2 to R3 value set, the R3 to R2 value set transition, you've actually got to go off and look up the code system and merge it in. And so that's an example of what you can do. Any other questions? I don't see any hands. Thank you very much.